Cool. So hello everyone. Welcome to our presentation, The State of Python Frameworks for Ethereum Development. My name is Jan, and I'm Ethereum Tech Lead at Eki Blockchain.
Hi everyone, my name is Michal Převrátil, and I'm the lead developer of security tooling for Ethereum at Eki Blockchain, where I develop two main tools, Vogue and Tools for Solidity. We will talk about both of them later in the presentation.
Cool. So what we are doing smart contract audits and also developing some open source security tools. And because of that, we are also onboarding developers to blockchain via online courses or teaching at the local university. So the first section, there is also we work with. So we work already with 1inch, Axelar or Safe, formerly Gnosis, and some of the last audited projects what we had. Is there anyone who knows Solidity? Oh, okay. Never mind. I will tell it to vectorized. It's an alternative to OpenZeppelin or Soulmate. They are gas-optimized Solidity snippets, so you should definitely check it out. It's some nice piece of code. So the first section is Python and Ethereum itself. So I will start with Python. So why we are talking about Python, why we are not talking about JavaScript or Rust. It's still the #1 language across many leaderboards, and it's used across a lot of tech industries, and still it is easy to read. And if we are talking about Solidity testing, it doesn't bother you by typing async await like JavaScript, or you don't need to cast addresses to interfaces like for the Solidity tests. So it is pleasure to write. And the last notable thing that Vitalik's loves it. So what are the verticals in blockchain development in Python? We have there some core blockchain and node software, like the EVM implementation in Python called PyEVM. Then we have some Pythonic languages for smart contract development, like Viper. Or integration libraries like the competitor of web3.js called web3.py. Then there is a big section about smart contract development frameworks. We will talk about that more later. And that a lot of security and auditing tools like Slither. And the last notable thing is a repository called Python execution specs. If you want to educate about EVM, this is now probably the best way to do it because yellow paper is in some way outdated. So there are some protocols, you maybe know them. Curve, Ear Finance, BadgerDAO, they started developing in a brownie framework, and some of them move to the Ape framework, but still they are using Python and Viper, most of them. And there is also a big community around the Python and Ethereum on Discord, and Viper has also its own Discord. So if we will check the timeline, we are somewhere in 2016 when web3.py was founded. And then it was followed by Slither, and first Python framework, first its release was in 2019. Then there was founded Viper, and after that was released two another frameworks, Ape and Vogue. This year we've got some new tooling, and it's a symbolic execution tool called Halmos, and it's from A16Z. So in this talk, we will focus on these three frameworks. We will compare them, check their advantages, disadvantages, and we'll see. So I'll start with Brownie. Just a quick introduction. It was the first alternative to JavaScript frameworks. So if you don't like JavaScript and still want to develop on Ethereum, this was your first time in 2018 when you could start to choose anything else. And it has contract testing via PyTest and hypothesis property-based testing. It's just derived from the Python native libraries, and it has also support for Viper. Unfortunately, this framework is no longer actively maintained. It has a lot of open issues, and also bugs related to them. So there comes the second framework, and guys from the ApeWorks are onboarding the users of a brownie. The project is heavily inspired by brownie, but it introduces some new features, like their so-called modular plugin system, where you have a core framework, and you can just use some other plugins, like plugin with Viper to get a support for Viper, and so on. And this framework is actively developed by ApeWorks. And the third framework where we will be talking about is Vogue, and I will give a word to main Vogue developer.
Oh, thank you. Thank you so much, Jan. So first of all, it's the name Vogue it's not connected to the movement. We just got the name package first, and then yeah. So it's not connected to the movement. And Vogue is in-house tool built by Eki Blockchain. I'm the lead developer, and so my opinions might be a little biased, but still, yeah. The name is Vogue, and first it was a static analysis tool and a language server. So when you launched your VS Code, installed an extension called Tools for Solidity, then Vogue got installed in the background, and basically all the requests, like go to definition, find all references, and things like that, rename symbol, and so on, went through Vogue. So Vogue was the backend, and the extension for VS Code was just a front end that communicated with Vogue. And also, as I said, it was originally a static analysis tool, so we got some kind of vulnerability detectors that can detect common vulnerabilities like reentrancy or unsafe self-destruct and things like that. As I said, we have an extension for VS Code, and except from the static analysis and language server, Vogue is also a development and testing tool. So you can basically write your testing scripts, your deployment scripts in Python, and execute them through Vogue. What's different from the other testing frameworks that we have introduced is that Vogue has something called PyTypes. And basically, when you have your project, which is in Solidity, because Vogue supports only Solidity, then you can compile the project, and then we generate PyTypes, which is like the equivalent of the Solidity project, but in Python. So for each contract, we have a class in Python. For each struct, error, or event, we have also a data class in Python. And when you interact with these classes or data classes in Python, you basically interact with the contracts on chains. And also, Vogue has an integrated fuzzer, so you don't need to use, for example, hypothesis with brownie. We have some kind of already integrated fuzzer, which also has some kind of advantages. Now, let's compare all the three testing frameworks that we've introduced by performance and then by user experience. Let's start with the performance. So what we did is that we took Uniswap v3 core repository that already contains tests written in JavaScript, in Ethers.js, and Hardhat. And we have migrated or rewritten the tests into all the three testing frameworks. And then we measured 271 tests multiple times, taken an average, and these are the results. And as you can see, Vogue is quite fast, especially with Anvil. We used some kind of cheat codes that Anvil offers, so we can be really fast because we, for example, don't sign transactions unless the user wants to. So we use some kind of cheat codes, but still, Ganache doesn't have these cheat codes, and we are, I would say, quite fast when compared to the other testing frameworks. So it's not only about cheat codes, but it's also about the architecture. For example, we decided not to use web3.py, which is like a big library in Python, because of the performance reasons. So yeah, we also created an academic paper with the measurements and submitted it to a conference. Now, let's talk about user experience. I have a few examples here. The first one is about cross-chain testing or multi-chain testing. And basically, this is how it looks like in Ape. In Brownie, we don't have a native support. We have checked the documentation multiple times, even the GitHub repository, but there's no native support. So basically, you can probably connect to some kind of network and then disconnect, connect to another one, but still there's no native support. And basically, in Ape, you have to switch between an active network. You can have multiple networks, but you have to always switch the network when you want to deploy a new contract or interact with a contract on a different network. And then in Vogue, we took quite a different approach, and we decided to build like the architecture from the very beginning in this way, so that when you deploy a contract, then you may specify a chain. A chain is basically the same as a network, but in Ape. And when you specify a chain, then the contract is already bound to the chain. So when you interact with the contract, you don't need to switch any chain or network. Basically, the contract remembers the chain that was deployed to, so you don't need to switch the chains, and you can normally interact with your contract and contracts, and everything works quite fine. And you can have basically as many chains as you want. The second example is a representation of data, because like you basically want to interact with some kind of contracts, with structs that are inside the contracts, with events, errors, and it's quite important to know how to interact with them and if it's user-friendly or not. So we have an example how we work with events in Ape, Brownie, and Vogue. So basically, you decode some kind of transfer event in Ape, then you make assertions when you can like use properties or the dictionary-like style. In Brownie, you basically have only the dictionary style, and well, you can have multiple events with the same name transfer. So Brownie doesn't really care about some kind of special cases, I would say. So for example, when you have a contract or two contracts with the same name in the same project, then Brownie won't compile the project because you have two contracts with the same name. So Brownie doesn't often care about the edge cases. And the third approach is in Vogue. And as I said, Vogue has something called PyTypes. So for example, here that IRC20 minimal is a class in Python, and the transfer is a data class, which basically looks like this. If you can see that, it's a data class. And what you do is that you create an instance of the data class, and then you can make an assertion that this instance exists in tx.events. What's really nice when you have these PyTypes is that when you are writing the script, you have type hints because you have like this structure already pre-generated in a directory. And also you have type checking. So for example, if we have used to is equal to pool instead of pool.address, then the integrated environment would like highlight the line because you have different types compared. So type hinting and type checking thanks to PyTypes. Also, one more interesting thing is maybe you have noticed that the event transfer has some kind of original name, and the from field it's not from, it's from underscore, and that's because from is a reserved keyword in Python, so we cannot use from, but we have some kind of metadata here, and the reason for that is that we support EIP 712, aka structured data signing. So when you have these pre-generated data classes, you can sign those directly in Python. You don't need to generate some kind of JSON and then sign the JSON like in other testing frameworks. You basically can sign directly the data class, which is quite nice. Another example is reverts. So let's say that we want to make an assertion that a special transaction reverts with an underflow error. And this is how you would do that in Ape, Brownie, and Vogue. As far as we know, there's not a better solution in Ape.
Backups with all the...
Okay. So yeah, you probably have to use this big number. It's not very nice, but it is what it is. The second approach in Brownie is that you use some kind of constant, like integer overflow. But as you can see, there's counter.decrement, so there's probably an underflow, not an overflow. But the error message it's hard-coded, and yeah, it's integer overflow. And the third in Vogue, well, like these panic errors are well documented. So we have an enum for this, and there are all the panic like reasons. So we have enum for these panic errors. Now let's talk about code coverage. Brownie and Vogue have code coverage support. As far as we know, Ape doesn't have it, but like it feels like the Ape documentation is a bit incomplete. So maybe there's a code coverage, but as far as we know, we have not found it. And in Vogue, we have an integration for VS Code. So basically, we can show the code coverage in VS Code. And what's really nice, as I have told you about the integrated fuzzer, is that when you fuzz your contracts, you can get your code coverage updated after like every 5 seconds. So you can see in the VS Code how the branches of the code are executed or not executed by your fuzzer, which is quite useful, I would say. And Brownie has a custom user interface. And this is how it looks like in Vogue. So we have VS Code, and we have some highlighted statements. Then you have exact number of executions for each statement. Then you have a percentage, which is always relative to the function body, or in case of function name, it's relative to all the function names in the project. And this is basically like how it looks like in the custom UI in Brownie. Okay, and I have 2 examples here. As Jan already said, we have audited Solidity recently, and these examples basically come from the Solidity audit. The first one is about Merkle proofs, and what's really nice, I would say, is that like when you want to verify or test a contract that verifies Merkle proofs, then you need to generate the Merkle proofs first. So you need a Merkle proof implementation, and I would say it's very easy to do this in Python, especially when you need to generate multi-proofs. And yeah, then when you have a Merkle tree implementation, which was like 50 lines of code, it was very easy when compared to the Solidity implementation. Then you can basically like fill your tree with some data, and then you can make assertions that the proofs are or are not correct. So I would say it's like very easy to use Python test to verify this kind of libraries. And the second example is ERC 1155 fuzz test. As I have said, Vogue has integrated fuzzer, and this is how it looks like. So you have a fuzz test class, you need to inherit from that fuzz test class, and then you have the contract that you want to test. And what typically you want to do is that you want to model the state of the contract, but in your code, in your Python. So basically, you are doing differential testing, which is useful especially in the case that the compiler would have some kind of issue because of optimizer, for example. So you would probably discover the issue because you are testing the code in a different language. But if you tested the code in the same language, then you wouldn't probably discover the issue. So basically, you want to model the state of the contract, but in Python. So that's why we have balances here. We have approvals. And what's really nice in Python that you have default dictionaries that behave basically like mappings. So you can set the default value if the key doesn't exist in that dictionary. And you have basically the same behavior as in Solidity, which is quite nice. Then we have some kind of initializer here. So we deploy the contract. We set the default dictionaries with their parameters. We want to generate some token IDs. But what's also nice that when you are generating a random data, you can specify the h-values probabilities. So that you probably want to increase the probability of generating 0, the minimum value, and the maximum value for integers. And then there's a flow, which is like a single executable step by the fuzzer, where in this specific case, we mint some tokens to a random recipient with some random amount, things like that. All right. Passing the word to Jan.
Okay, so just quickly to sum up, based on our experience by writing the academic paper, Brownie has discontinued development, but still feels more stable than Ape. Ape takes everything what people loved on Brownie and trying to do it better. And Vogue is blazingly fast, and Brownie an architecture different from Ape and Brownie, with a focus on developers' comfort and security. The developers' comfort is signified by type hinting in tests, which is the only feature which Vogue has, apart from Brownie and Ape. And but on the other hand, it doesn't have Viper support. Coverage reports are available for Brownie and Vogue. GAS reports only for Brownie and Ape. And Vogue has some other features like integrated fuzzer engine, static analysis based on built-in LSP server, and Ape and Vogue has active development. And all the frameworks have in common that they love Python. So there are some resources what I used, and a little bonus. There is a Vogue ape eating a brownie. So Thank you, Midjourney, and thank you all for your attention.
Thank you. Do we have any questions to kick off? Anyone? I'm checking the chat. Just have one comment. This is interesting. So I don't see any hands or any questions. Thank you, guys. We'll go to the next session now.
Okay.
Thank you.